The following video is brought to you by a group of engineers at Louisiana Tech University.
According to the U.S. National Library of Medicine, roughly 75% of Americans are chronically dehydrated. This can lead to lethargy, fainting, and even death. Let us tell you a story about Henry White. Henry White was a student at Grambling State University in 2009. One day, when he was late to basketball practice, his coaches made him run laps outside. Shortly after he finished running his laps, Henry passed out, and 12 days later, he passed away in the hospital. With summers becoming hotter each year, it's also becoming harder for us to stay hydrated, and we need to focus on drinking the right amount of water so that we can stay healthy and alive.
We wanted to be part of the solution, and that's why we want to introduce you to the product we made, which is called the H20Flow.
The H20Flow is a straw that tracks how much water you drink. It contains a flow sensor and a small Arduino, which is about the size of a quarter. When you drink water, the flow sensor tracks the amount of water you drink, and it tracks water in both directions, which is why we added a camelback bite valve onto it. When it stays closed, the water doesn't flow back into the sensor, and that keeps the measurements accurate.
We chose the camelback straw in particular because it's made out of a medical grade silicone, which means it's very tough to tear, bend, break, or anything like that. And that'll help us with preventing water leaking and keep the system watertight. I'm now going to do a demonstration of how the straw sends the data to the computer. So if I take this cup of water here and I start drinking out of it, you can see the value go up on this monitor. Now, if I remove the straw, no water is able to come out, and it doesn't affect the data of the computer. But if I can give it a little flick and let the water slowly flow out of the straw, it doesn't affect the value of the monitor either. That's what we wanted in order to ensure that you can get an accurate reading of your data.
Before we decided to make a straw, we first planned on working with water bottles. Our first idea was to use an ultrasonic sensor under the cap of the water bottle, and that would detect the distance between the top layer of the water and eventually the bottom layer once you drank from it. Then we would subtract the final distance from the top distance, and that would give us the amount of water that we drank. But that didn't work out because water would move around inside the bottle, so that would make the measurements inaccurate. Our next idea was to work with a basket that we would put the water bottle in. This basket would contain a sort of weight sensor, and just like the ultrasonic sensor, we would use it to measure the weight at the top, and then the weight at the bottom, and then subtract the final weight from the top weight, and that would give us the amount of ounces that we drank once we translated it in the code. This idea wasn't optimal either because it wouldn't account for whenever you decide to fill up your water bottle. So finally, we decided to go with the straw. This straw was our best idea because it could be used in just about any water bottle, any cup, any mug, and it was just a very versatile option.
In order to create this straw, we needed to have an understanding of mechanical and cyber engineering in order to be able to create a small enough product that can function with the code we needed in order to read water levels. We were able to accomplish both of these goals and create an affordable product to place on the market, and we intend on developing it further. This has been our product, the H20Flow.